Hello, everyone. My name is Nia, and welcome to today's webinar. We'd like to give everyone a minute to join and settle in. Please use the chat and let us know where you're tuning in from. I myself am tuning in from New York City. If you're just joining, please use the chat to let us know where you're tuning in from and make sure you're putting to everyone because there may be someone in the same location as you attending this webinar today. We love to see everyone joining from all over the world, from Mexico to Kenya to Indonesia, all over the US, Ghana, India, Brazil. I love the Boston enthusiasm. And hello from the UK. Sierra Leone. Well, thank you everyone again for joining today's webinar. And we're gonna kick it off very soon. We just like you all to settle in. And if you're just joining, please drop where you're tuning in from in the chat and make sure you're putting to everyone, because I do see a couple of people that are attending this webinar in the same location and or country. Okay, it looks like we have a good amount of people, so I'm going to go ahead and get started. I'm happy to welcome you all to today's webinar, Intro to Data Modeling. We have Michael Lin in today's presentation, and we have Associate Solutions Architect Christian, who will be answering your questions in the Q&A panel throughout today's presentation. But before we start, we're going to go over a couple of quick housekeeping notes. This recording will be shared later this week. All participants are muted, so if you do have any questions, please drop them in the Q&A box at the bottom of your Zoom panel. The Q&A has a question mark in the box above it, and it just says Q&A on your Zoom panel. Please use the chat only for live comments and general discussion only. If you do have any questions, of course, please drop that in the Q&A box. There will also be a short survey at the end of today's presentation, so please take a moment to fill that out before you leave. Thank you again for joining today's webinar, and I'm going to start the presentation now.
What is data modeling? I know you're all joining with that question in mind, and I'm going to answer it today. We're going to take a look at the difference between RDBMS and MongoDB. We're going to look at relationships in data and how we represent those relationships through the process of linking data elements versus embedding them. And then we're going to take a look at some design patterns for commonly expressed relationships between data elements, whether it be one-to-one, one-to-many, or many-to-many. If you come away from this webinar today with one thing, I'm hearing some feedback. Diego, yeah, there you go. If you come away from this webinar with one thing in mind, I want you to remember this mantra. This is a mantra that I use whenever I start a data modeling project with MongoDB. Data that is accessed together should definitely be stored together. Okay, I'm going to explain a little bit more about this as we go forward, but I'll be referencing this slide and our mantra throughout the webinar today. So let's talk about what data modeling is. What is data modeling? Well, it's simply put, the process of figuring out how to represent and store data in your database. Okay, why is data modeling so important? There are several benefits. The first of which is better performance. When you model your data effectively, efficiently, your applications will perform better and your users are going to be more happy. The implementation of your application will be simpler. You'll lower costs associated with storing your data and managing it, and your application will have better adaptability going forward. Why then is data modeling so often overlooked when it comes to MongoDB? Well, there are several reasons, but the first is that people have this concept of NoSQL, not only SQL, and they feel like they don't have to do that data modeling exercise with a NoSQL database. Well, let's strike that term from our vernacular today. You may also have heard the term non-relational. We're going to strike that term too. We're going to start using the term non-tabular. Okay, when we talk about MongoDB being a document-based database, we're going to call it non-tabular because there are no tables. And speaking of vernacular and vocabulary, here are some common phrases that I'm going to be using today in our journey to understand data modeling in MongoDB. First of which is database. It's the same in MongoDB between non-tabular, relational, and MongoDB. The second is collection. It's more common in the tabular space to call data entities stored in a table. We're going to refer to those as being stored documents in a collection. Parent-child tables in RDBMS, they become nested subdocuments or arrays. Indexes are common between RDBMS and MongoDB. And where you see a row in a table in RDBMS, we're going to refer to that as a document of fields. And then a column becomes a field, and a join in RDBMS, if you're coming to us from SQL, MySQL, one of those tabular databases, you are probably familiar with the concept of joining data because you have to be in a normalized world. We're going to refer to that as embedding or linking, and we use the term $lookup to refer to an operator that enables us to join data between data in multiple collections in MongoDB. So I hope you'll come back to this in the future when you are curious about some of the vocabulary that we're referencing today. There are other non-tabular databases. We're going to focus today on document databases because MongoDB is firmly in the world of document databases, although we do support additional types of indexes, but we're going to restrict our information today to document databases. So then what is a document? This is a document, and many of the programmers among you, developers, will say, I recognize that, it looks like JSON. It sure does. It's because it is. When we refer to the data that's stored in MongoDB, it looks like JSON, tastes like JSON, smells like JSON. JavaScript object notation. It begins with a curly brace, and it ends with a curly brace. And in between, where the fun happens, these are key value pairs. These are fields. Okay, so keys are always going to be string. Title, for example, is a string. The value can be a string, it can be a number, it can be an array, it can even be another document. In the case of reviews, we have an array of additional documents. So if you're brand new to document databases, this might look a little strange, but don't worry, we're going to explain it. These book documents go into a collection of documents. So we have many of these book documents in our collection, and we're going to reference exactly how we lay this out. Another reason that people think they can overlook data modeling in MongoDB is that there's this concept of schema-lessness in MongoDB. There's no schema, right? Well, no, it's not actually a schemaless database. And it is not equivalent to a JSON data store because we store this data on disk using something called BSON, a BSON representation of the JSON data. That enables us to be very rich in the types of data that we store. We store more types of data than JSON supports. Date types, for example. In JSON, they're stored as strings. In BSON, they're stored as fully supported date objects. This helps us when we develop code. With RDBMS, Every database has an explicit schema, and that lives outside, separate from the data. The schema in RDBMS lives separately from the data. Whereas with MongoDB, it lives in the data. With MongoDB, we say that every document has an implicit schema. And from document to document in a single collection, we can have different schemas. This is called polymorphism. Poly meaning many, morphism meaning shapes, many shapes. We also refer to this as schema on read. The schema exists when you read the data and look at it. Okay, so this also supports a greater level of flexibility. When I want to, let's say, add a field to my data, looking at our book document here, I want to add, let's say, publisher and a schema version. I can simply add those fields to my data, changing the schema in this particular document. This supports greater developer velocity. We can just simply modify our code to increase the fields that we're supporting in our application. And if you wanted to look at maybe a snippet of JavaScript, this is what that might look like. This is using the Mongoose library. It's referred to as an ODM or an ORM. And here we're adding publisher and schema version. Now, you don't have to use Mongoose. You can simply write native JavaScript code. But that is an example for you. So one last reason why data modeling is often overlooked with MongoDB is that folks have this idea that they can come to MongoDB and simply leverage the same design patterns that they used in the RDBMS or tabular world. This is going to lead to poor performance in almost every case. This is why you need to pay attention to webinars like this, data modeling for MongoDB specifically. We're going to help you build a data model for your application so that you'll have fast, efficient access to your data. So then, what does data modeling look like for a document database? Let's take a look. This is one of the most important slides. I want you all to stop what you're doing, stop checking email, look at the screen, screenshot it. This is the secret sauce. This is the recipe that is going to enable you to build an effective data model for any application you're writing. This is a generally applicable set of 5 rules. The first, screenshot. Yes, definitely. Stop breathing. No, don't stop breathing, Claudio. Okay, so the first is you want to always begin the process of data modeling with MongoDB by collecting your system and application requirements. What requirements of the application are there? We're going to get into that. 2, identify the database entities and their properties. Now, this is a tricky task, but I'm going to help you understand exactly how to do this. And I'm going to even give you a little template that'll help you get started there. 3, determine the database workloads. This is the access patterns of your application. You need to understand these before you begin to nail down your data model for MongoDB. You want to write these down, write down the common operations and the frequency, and take a guess at the criticality of each of those workloads. 4, you want to identify the relationship between the entities in the application, choosing between an embedding model and a referencing model. Now, I haven't explained what embedding or referencing is yet, so hold on to that concept. You can just kind of put that in cache. 5, apply appropriate design patterns if and when necessary. We're going to give you some of those design patterns. That was one of those links from the beginning. When we talk about collecting system and application requirements, there's a couple of categories of requirements that we're going to have with every application. The first is your functional requirements. How does the application need to function? And you can look at this through the lens of the types of users that you have. Typically, we have at least 2 classes of users for every application. There's going to be regular users, and there's going to be administrators. And in today's case, we're going to call those administrative users librarians because we're going to work on a library application. That's the lens that we're going to view data modeling through today. I can't really understand exactly what you're building today, but I'm going to use a fairly generally applicable application for a library because we've all read books, right? And the last category of requirements is going to be performance requirements. How much data and what are the expectations around the volumes of data and the speed? Okay. So I explained this already. We're going to be working on a library management system. We've all been to a library, or at least understand the concept of a library. Let's look at our functional requirements. Now, this is a really dense slide. I don't want you to sit here and read all of these things, but we do need to take time to examine our requirements. And as I mentioned, we have two classes of users in our fictional application, readers and administrators or librarians. Let's look at our reader requirements first. A reader in a library is going to want to always browse a catalog of available books. That's a fairly straightforward functional requirement. Second, view the extended details of a book, right? So if you click on a book, you want to see more details. You want to be able to reserve a book and check it out. You want to be able to see a list of all the reservations, the book loans that you've had. You want to be able to see all the books that you borrowed, and then view the details of an author. Let's look at other books that this author may have published. From a librarian's perspective, they're going to want to see a list of all reservations that have taken place and their expiration time, a list of all borrowed books, including the due date. They're going to want to filter reservations by borrowed books by user, and then they're going to want to actually execute the process of lending a book to a reader and mark that book as returned when they bring it back. So the second category, as I mentioned, is performance requirements. Let's look at our data. Now, some of this you may have, and some of this you may have to guess at, and it's okay to guess, but you do need to do some of this work before you begin your data modeling process. In our library, we have about 10,000 active readers. We have 250,000 books. Readers are going to consult the library website on a weekly basis, typically, and borrow books every month. Most readers are going to reserve and borrow about 3 books a month. These are guesses and they're estimates. Reservations can be made online through the application, but books can only be borrowed on site. And our readers rarely read more than 3 book reviews. The system we're writing is going to support reviews. Okay, I love that. We're getting some great questions in the Q&A box. Keep those coming. We're going to end in approximately 30 minutes, and we're going to answer some of these questions live. So keep those coming. In terms of our expectations, the book details page is going to show book availability, and it should refresh. It should show the details in less than 300 milliseconds. That's a typical response time for any application. 300 to 500 milliseconds is generally acceptable. Readers should be able to reserve a book in less than 3 seconds. It's got to be snappy. We want really good response time. Librarians should be able to lend a book or mark a book as returned in less than 3 seconds. And readers should be able to see the list with all of their reservations and borrowed book in less than 500 milliseconds. So this is a pretty good, well-defined set of performance requirements. And you may have some of these details and you may not. It's okay to make estimates. My mouse kind of went nuts there. So if we were to look at what this application might look like, here is the opening screen for our application. Here you can see a nice banner. That link is actually functional. It's going to take you to this example application. I won't be able to answer your questions about details about this application if you do go to that link, but I'll do my best. And then, so what you see here is a tiled list of all the books that are available, and we're going to go a little bit deeper into that application shortly. So let's talk about a methodology for understanding how we can begin to model data for our application. This is a really great kind of waterfall flow of activities that you're going to undertake when you start to model your data. We start with entities, okay? Start with understanding what the elements in the data, understand their sizes, and let's dive into that. What are the main entities that are used in our system and that we're going to be storing in our database? And what are the properties of these entities? So for example, every reservation has a due date, every review has a score, every book has a title. This is going to be the process of looking at what our application is going to manage in terms of data. That's going to help us before we start talking about the relationships and how to lay it out on disk. I've done the process here for you for this fictitious library application, but you're going to want to go through in detail and answer all of these questions specifically. Let's take a look at one of the entities in our application. Authors represent something unique because there is a relationship between books and authors. And this relationship could be represented in one of several ways. It is a book property, but is it a separate entity? In the relational world, you would almost always create a separate table for your authors. In the non-tabular world, you do not have to do that. And I'm going to show you how to determine whether you would reference or embed. Let's take a look at that. So our properties for authors, they have names, they have aliases, and their names are not unique, okay? So let's go back to our functional requirements to shed some light on whether or not this should be a separate entity or a separate collection. And the final set of functional requirements is going to give us a clue. We have to be able to support the workload where a user can view the details for an author, including all of the books that they have published. Okay, this is a clue. View the details for a specific author, including all their books. This is an access pattern that I'm going to show you. This is a GIF that, okay, so I'm looking at the main screen here and I'm going to click on an author. Let's go to F. Scott Fitzgerald. And here I show all the details for that author as well as the additional books that they published. This workload, this use case, this access pattern is a clue that we may need to treat authors as a separate entity. The query is going to be separate from books, okay? So in this case, I may choose to store authors as a separate entity. Back to our mantra, data that is accessed together should be stored together, but on the flip side, data that is accessed separately should be stored separately. If I were looking at this from the perspective of an entity relationship diagram, and imagine that that little thin line between in the center is separating the world of relational database management systems on the left from the world of document databases on the right. If I were to store authors as a separate entity, this is what my entity relationship diagram for MongoDB would look like on the right. Okay, on the left, I'm normalizing the data and separating it always. There's a separate table for authors always. But on the right, I have a choice. I have embedded some of the data for books, and I've separated into a separate collection authors. If I were to reference this in code, JavaScript specifically, this is what a find one might look like. Database.collection, authors, and I may find one based on a filter. Okay. Now, conversely, if I wanted to treat authors as an embedded element in my books collection, this is what that data model would look like. Again, on the left, we have our relational model where we've normalized our data into separate tables. But on the right, I'm representing the MongoDB data model where I've embedded author, name, and biography right in the same document in the books collection. Okay, so this is a comparison and contrasting and referencing model versus an embedding model. I hope this is beginning to make sense for you. If not, please feel free to use the Q&A box to ask questions. Data that is accessed together should be stored together. I hope this is getting drilled into your head. I hope this becomes your mantra when you begin to do data modeling with MongoDB. And the converse side of that, the flip side, is data that is accessed separately should be stored separately. So in this case, authors are going to be stored separately. So we'll need to join that data. Let's take a look at workloads. In our waterfall, we've gone from defining our entities to now discovering and documenting our workloads. We're going to quantify the operations and qualify those operations. So don't skip this step. Please understand your workloads. In the relational world, you can just begin to normalize your data before you really truly understand what the workloads look like. In MongoDB, the importance of this step is paramount. How many requests are you going to expect? How critical are these operations? And what type of latency is reasonable? These are questions you're going to want to ask yourself in every case. Here's your template for your workloads. I want you to define the type, the operation first, the information required, the frequency of the operation, and its criticality. So the first workload that we're going to look at is showing book details. Okay, what type of operation is that? Is it a read or a write operation? Well, show book details, I mean, it almost answers itself. It's a read operation, but what what types of information are we going to, good answer. It is read. So what information are we going to show? We looked at our application and it looked pretty clear. There's title, but some other information. Let's go back to our functional requirements and answer this question. Our second requirement was that we be able to view the extended details of a book, including author, synopsis, title, physical copies, reviews, and other readers. Okay, so I'm so glad that we took the time to document our functional requirements, because now we can go back and look at what that might look like in our application and then document it in our table. We're going to require book title, cover, author, reviews, and availability. Let's go back to our requirements and look at our performance requirements so we can further answer this workload question. Readers rarely read more than 5 book reviews. So that tells us that for this specific exercise, we only need to support 5 book reviews. Okay, so the operation is gonna reference at least 5 reviews, or the last 5 reviews, sorry. And what is the frequency? Okay, back to our requirements. The library has 10,000 active readers. Well, as much as I hate to do it, math enters our life in so many different ways. We need to do the math to understand what the requirements for our application is going to be. The library has 10,000 readers. Okay, well, that's divided by 7 days. So if we want to get to a daily figure about the number of users, active users per day, so 1,400 users per day. But what does that mean? It doesn't mean anything unless we start to look at the volumes of data. Well, okay, so we said they're going to read on average 3 books every month. So that means 4,200 rented books. Our application is doing pretty good. We might be able to go public soon. How many books do readers browse before reserving? We're going to have to take a guess at that. Let's assume 25. So if we do the math, we extend the math, we have 4,200 rented books times 25, which is our estimate. That's about 105,000 book views. And if we assume that each book document, based on the entity data that we provided, is going to be less than 1,000 kilobytes, then we can do the math. 1,000 kilobytes times, the slide is incorrect, but we'll fix that. 105,000 views, that's about 1.2 megabytes of data. So fairly low volumes of data. We're not going to have to shard this for sure. So we'll document that. We have 100,000 K per day, which is equivalent to about a megabyte per day. This gives us a criticality of a medium. And we can do this exercise for literally every one of our operations. We don't have time today to go through each one of these, but I want you to understand the methodology that we follow. This is the data modeling methodology that we follow for literally every data modeling exercise. And I want to give a shout out to the folks. There's a portion of the developer advocacy team at MongoDB that do these exercises with customers. So if you're a customer of MongoDB and you're interested in having someone go through a design review, there's a specific team. So reach out to your enterprise account executive and ask them about the design review team. And we'll go through this process with you. Let's move on from workloads to further defining the relationships. Okay, now that we understand the basic entities, we understand how those entities are used in our workloads. Now we want to understand the relationships between the data, and we can begin to bake our data model. Remember our mantra. This is so important. I'm not even going to say it. I want you guys to say it. Data that is accessed together. Good. Okay, I can almost hear you saying it. Data that is accessed together should be stored together. All right, so let's look at some relationships. There are several common patterns, and this is regardless of the type of database that you're using. There are relationships. Yes, I love it. Together, yes. Nice work. So there are several types of common relationships between data elements, and these exist across any type of database that you're using. There's going to always be this one-to-one relationship. So for example, we have one title for every book. Books don't commonly have more than one title. And if they do, we're probably going to store it in a separate book document anyway. So it's still going to be a one-to-one relationship. This is what that would look like if that were the only data element. We would have a book document with a title. Okay, so for one book, we have one title. That's a one-to-one relationship. There is another type, which is one-to-n or one-to-many. And a good example of that is book genres. One book, Brave New World, can exist in many different genres. It can be science fiction, it can be dystopian, it can be a novel. Okay, that's a one-to-many relationship. And there are also there's also a trickier, this is a more difficult pattern of relationship to understand, but it's many to many. So a good example of this is authors to books. One book may have many authors, and one author may have many books. That's a many to many relationship. Now, we can even further refine this, but we'll put that on the shelf for a moment. We're going to talk a little bit more about embedding versus referencing. I showed you an example of this earlier. We're going to go a little bit deeper into this. Now, we showed you the document that represents the book. We're storing our book details in a document in MongoDB, and this is what that looks like. Take a look at the reviews field. So our review field is embedding an array. That square bracket is indication that there's an array of data underneath this field, okay? And this can be n elements in an array, and each element is another document. So each review has a user field and a text field. And I would imagine it would have a rating as well. This is kind of an abbreviated example. So here's our embedded field, reviews. So when we look at the one-to-many relationships, when we embed, there's several ways to represent that. We can embed on the one side or on the many side. If we embed the data on the many side, then we are going to create a separate entity for reviews. We would flip the book data model and store on the many side. And what you're seeing there is a collection of review documents which back reference the book. And I might actually include an ID in the book field. There's our embedded book reference. Now, this does lead to duplication of data, which is a giant no-no in the tabular world. To normalize data is to reduce duplication, but we don't care about that in MongoDB unless it impacts our performance requirements. You can also reference on the one side, and this is what I was talking about earlier, where the book document would contain a reference to the reviews collection. So here on the one side, we have the book, which has a many side, which is a review. So the left side is going to be a collection of books, and there's going to be a unique identifier of an array of reviews in the book document, which reference elements in the review collection. So here's our embedding, our embedded reference of IDs to each of the reviews in our reviews collection. So this is a one-to-many example where we're embedding and referencing on the one side. Okay, and here's an example of referencing on the many side. Again, we flip that around where we have an ID, a book ID, and reviews contain a back reference to our book. So there's many ways to reference this. And again, the answer is, it depends. How do I know whether to reference on the one or the many side? It depends on the access pattern of your application and the performance requirements that you documented earlier. So you're always going to go back to that process of documenting your entities, your workloads, and the use case that you want to support. Now, there are some things to remember about these two ways of representing relationships, whether you choose to embed or you choose to reference. First, embedding is going to lead to a single query to retrieve all of your data. The more you embed, the less you have to read. A single operation is going to be required to update or delete data in an embedded model. This does lead to data duplication. And it also can lead to large documents. Does anybody know, I'm going to ask a little trivia question. Does anybody know the maximum document size supported by MongoDB? Yeah, right. Yes. It's 16 megabyte. Several people got it. 16 megabytes is the maximum size you can store a document. That's a pretty big document, by the way. There are ways you can use GridFS, by the way, if you want to store a set of documents larger than 16 megabytes. On the referencing side, well, there is no duplication. Okay, so you're gonna break things down. You're not going to duplicate data. This leads to smaller, larger numbers of documents. But now you have to figure out how to join that data the same way that you do in the relational world. And again, I gave you a clue earlier. The operator that you're going to want to reference is $lookup. There are several others, but $lookup is the main one. So this comes down to a choice. Is it the red pill for embedding or the blue pill for referencing? Who gets that reference? So cardinality is something that you need to consider when you make this choice. Yes, it is. It's a BSON imposed limit. Yep. So cardinality, as it relates to expressing these relationships, in a one-to-few, you're going to access them together. They're going to belong to one entity. And an example of one-to-few is books to genres. Probably not going to be a zillion genres. It's going to be a relatively smaller number. And users to addresses. How many addresses can a single, or does typically a user have? Not many. It's going to be few. So an example of this, embedding on the one side for a one-to-few relationship would look like this, where we're embedding addresses for a user in an array. One of the anti-patterns that we reference in when we data model for MongoDB, an anti-pattern is storing large numbers of elements in an array. It's not going to be a good idea because if you have to traverse that array, it's going to cost you in terms of performance. Okay, so take a look at cardinality. So when you have a one-to-few, like users to addresses, leverage embedding on the one side. Let's take a look at the other opposite end of the scale, one to zillions. So an example of this would be like an article page to views or visits. You could have zillions of views on a particular article, right? Or process log messages. There's going to be zillions of those depending on the frequency of your application. So in this case, there's really no risk of exceeding the document size limit when you reference on the many side, okay? Because the document's going to be very small, but there's going to be very many of them. But you should be extra careful when querying the zillions collection because it's going to be very costly. And you're going to want to take a look at indexing to support a very performant workload. This is an example of one to zillions, and we talked about articles and page views. And the last one that I want to show is one to many. So you need to ask yourself, are you going to access both elements separately very often? If you are, then you want to reference usually on the many side of the equation. If not, then embed on the more often queried side. And if you're not sure, reference unless you're looking for simplicity and you're not afraid to migrate later. So some good advice there. Here's another template for you. It'll help you answer the questions around relationships between entities, and it will help you quantify them in terms of the common relationship patterns that we talked about: one-to-one, one-to-few, one-to-many, and many-to-many. Okay, so you're going to answer the question embedding or referencing, and we always want to go back to our functional requirements. The last one gives us a clue. View the details for an author, including all the books they have published. This is going to be queried separately. Okay, so this always goes back to our functional requirements. And in this case, I'm going to most likely choose storing authors separately. Okay, so this is what that would look like. Author is a separate collection of documents. And then I'm going to store authors in an array because it's not always going to be a single element. There might be multiple authors for a single book. Okay, so we'll answer that question and we'll document it. By the way, can't stress this enough. You really should have good documentation about the choices you made for designing your data model. It's going to help you when you're working with other developers. Here are some guidelines that you can use to determine whether or not you should be embedding or referencing. We have some simple guidelines. Okay, so simplicity's sake tells you, would you be keeping the pieces of information together to keep your data model simple? Then just embed. I love this because it leans toward our mantra: data that is accessed together should be stored together. We like to keep it simple. I'm not going to go through each one of these for the sake of time, but these are our guidelines. Maybe put a little bookmark in the time. We're at 40 minutes in. You can come back to this and read all of those. We're going to further define the relationships between our data elements, and we're going to document those. In our library application, we've got a book author relationship, we've got a user borrowed book relationship, we've got a user reservation and a book reservation and a book review. And here we're making, in almost every case, we're making the choice to reference rather than embed. That's not always the case, but for our specific application, that makes sense based on our functional requirements and our performance requirements. Lastly, I want to talk a little bit about the patterns, some design patterns, and then we're going to wrap and take some questions. So common design, schema design patterns. There's a computation design pattern where you can pre-compute data and store that in your data model, in your schema. There's a grouping where you can group common data elements or calculated data elements in your data model. There's a lifecycle pattern where you're going to, ahead of time, think about the archival lifecycle for each document. This is going to give you the ability to automatically archive data. And you can use things like a time to live index where your documents are moved out of the collection over time. There's the polymorphic design pattern where each document in your collection can have a unique design. It can have a different shape. And what that supports is a single collection. And lastly, there's the relationship design pattern guideline. And I want to point out that these design patterns are documented fully in a blog article that's on the MongoDB blog. It's under data modeling design patterns.
All right, thank you so much, everyone, for joining. We're going to go into the Q&A soon, but we just launched the poll, so please take a moment to fill that out. We'd greatly appreciate your feedback. The new free online MongoDB data modeling path will show you a step-by-step method for creating effective data models. You'll learn how to identify entities and workloads, map relationships, and when to embed or reference them. In addition, you'll learn different schema design patterns, how to recognize and address MongoDB anti-patterns, and the basics of schema lifecycle management. Upon completing the learning path, not only will you feel prepared to take the certification exam, but you'll also automatically unlock a 50% discount on the exam. You will receive an email with code that you can use at checkout when you schedule your exam. I'll drop this in the chat for you all, so make sure you explore MongoDB's new learning path. And please remember to answer the poll that we just launched. Please share your feedback with us, and we are going to join the Q&A now. So if there are any questions, please feel free to drop them in our Q&A section as we have a couple of minutes left. Also, as a reminder, the recording of this will be shared along with additional resources and links that were shared in the presentation today. So we're going to give this a few minutes and wait for some questions and some more questions to come in. Thank you all. And if there are any questions that are not topic specific, please use our MongoDB community developer forum. I'll also drop that in the chat for you all. And make sure to register for more of our webinars as well. So please keep a lookout in the chat for some links. If you guys have any questions, please drop them in the Q&A so that our solutions architect, Christian, can answer those questions for you live today. I just dropped the community forum in the chat where you can ask questions, other questions outside of this topic here. Also, if you'd like to speak to an expert about your specific use case, please make sure you're checking off yes in the poll at the end of this webinar.
Yes, we will be emailing links out that are in the chat.
Okay, if there are no more questions, we're going to go ahead and wrap up. We thank you all for joining today's webinar. Please be sure to register for more of our webinars. Let me drop that link in the chat as well. We have an Intro to Vector Search webinar coming up, so please stay tuned for that and register, along with some other webinars around our AI capabilities. So make sure you stay tuned, and thank you all again for joining. Have a good rest of your day, evenings, and great weekend. I guess we can probably take one question that just popped up. Christian, if you'd like to take it, and then we'll wrap up.
Yes. So MongoDB's data modeling would be contributing to the latest LLM advances by also retrieving and returning custom responses as quickly as possible, while also understanding your questions semantically and be delivering the responses that much faster.
All right, thank you so much, Christian, for hopping on and answering the many questions. Thank you for that last question. We're going to wrap up now. Thank you again, everyone, for joining, and have a great rest of your day.